Well, welcome to this very special edition of Voices of Video. So, you probably don't know it, but this actually is a different format here. Normally, we go live on LinkedIn and other platforms. Today, we are recording, and that has a lot of advantages. One is that we can bring in experts from literally around the world and we don't have to worry about navigating time zones. And it also gives us some flexibility to, create some new types of content, do some screen sharing, etc. So I hope you like this new format. And if you do, make sure you let us know. But this edition of Voices of Video, I am talking to Keith Chow from Nokia. So, first of all, welcome, Keith, to Voices of Video.
Thank you for inviting me here.
Yeah. Well, I know that you are quite prolific, and meaning that you speak, you travel a lot, you're out there in the industry. I think a lot of our listeners may even know who you are or have heard your
Yep.
talks. But why don't you give an overview of what you do at Nokia and what you're focused on these days?
Yep. I'm Keith Chow. I work in Nokia, IP routing, IP network, and network infrastructure group. And my main job is the senior product manager, and I'm also doing some other support things like pre-sales and also post-sales support, and also for funny things with the Bell Lab team, because I work very closely with the Bell Lab guys, and they are the blue sky thinker. And the
Yes, they
product
are.
I'm working with, I look after is the mainly for IP video in Nokia, and it is Bell Labs innovation project. Okay, many years ago, and they started with something very special and very difficult to implement in life in product, and we transfer the blue sky thinking into the product reality, and also making quite a good impact in the industry.
Amazing. Yeah, very cool. Well, you recently gave a presentation that we're really going to use as the basis of our conversation today, and I can't wait to dive into that. You know, now even Netflix has live sports, right? So it's no secret that video platforms have been transformed. They are now live streaming platforms, and that brings in the question of latency. There's a lot of talk about needing to get to broadcast latency, and then there's some very interesting use cases that I know you'll be talking to us later about, with like sports betting and other interactive type uses where really getting into second or even sub-second latencies is critical. So I'm wondering if maybe you can give us your perspective, around the importance of latency, why, why streaming services should care about that.
Um, okay. Streaming service very important is that they need to separate the different, understand the difference between live streaming and from video on demand. The different is the nature of real time. Okay, nature, and also real time and sport or real time live event. They have a very high concurrency. Typically, we measure it in the network is between 50 to 70%. The worst case was 100% concurrency
Hmm.
with one of our customer in the World Cup. Okay, so you understand that in the World Cup, everyone will watch the football, and no
Mhm.
one exception, and so it's very high demanding, and also they demanding a minimum latency. And for the IP broadcasting, the platform will adapt that with RTP base or similar to UDP base. For
Mhm.
example, in Amazon, they bought the company called Sci.
Mhm.
They're using Sci technology. is a UDP paste, and Google also using Quick, the UDP paste, and
Mhm.
WebRTC is UDP base. Okay, so they're all one single trend is that they're all going to UDP basis of
Mhm.
or solution to deliver the low latency and scalable stream. For example, to scale up, we might need to use the technology called multicast, and a lot of people may scare off the multicast because they have
Mhm.
no knowledge how it works and how the ISP will react when they ask them for multicast enabled network. Actually, it's
Mhm.
very simple. One of our customer, they do not have the network and they need to deliver multicast streaming, live
Mhm.
event, and 24/7. And they managed to negotiate with 7 different ISP in the country, even
Mhm.
more. And so it's not that difficult when you tell them that you're going to have a few terabit going through
Mhm.
your the network. They will think
Mhm.
about before they are going to say no. Because if you're
Mhm.
capable to deliver a terabit concurrent stream into their network, they will think first, say, wow, okay, what am I going to do? I'm going to charge them few a lot of money to do it, or let them just pass through and they route through another interconnection uh, service provider, and then
Mhm.
it push up the cost for them significantly because they can route through someone else and not directed into the peering. So
Mhm.
they managed to agree this sort of agreement to make sure that they can stream multicast, and where they cannot stream multicast, they use a router unicast based on RTP protocol.
Mhm.
So they can also, we are using MPEG transport stream, so it can be easily synchronized in all the player, because MPEG transport stream have the is presentation timestamp and also have the PCR synchronize all the device in the network payback. So they are all streaming this, all the device, they are all synchronized the payback time and real-time interaction. And also
Mhm.
we introduce something called fast channel change, which is unicast base to support the fast acquisition of the multicast.
Mhm.
So we can optimize the MPEG transport stream. For example, they can use your chipset for the VPU to
Mhm.
reduce the encoder buffer size. That is the critical path of the MPEG transport stream in the live broadcasting, because if they can reduce the MPEG transport stream, the encoder buffer, they can reduce the latency because the device
Yeah.
will need to buffer the encoder buffer before they can start. So we can also optimize that part during the fast channel change. So we can
Mhm.
start the decoding within 90 milliseconds or to whatever when the iframe and the audio packet will arrive at the decoder side.
Mhm. Yeah, amazing. Now, this is Nokia's proprietary solution, but why don't you go into a bit more detail about explaining the components of it? Because I think, in the industry, and I'm just making a general observation, there's a lot of claims. You walk around like NAB or IBC, and it seems like every vendor has their ultra low latency solution, their low latency solution, and whatever tag they put on it. And often you look under the hood, and it's WebRTC, you know,
Yeah,
or maybe, they have adopted, some UDP, protocols, and, maybe they've done a little bit of, shall we call it, customization. But at the end of the day, it's really just very standard, run of the mill, off the shelf. And often it doesn't really work that well.
yeah,
Nokia has taken a different approach, still using standard technologies. So,
yep.
what, yeah, why don't you explain that?
Okay. The standard protocol we use must be standard. Okay, whatever protocol we're going to deploy
Hmm.
in the company's rule, it must be standard. Okay, it must be part of the IETF. It must
Hmm.
we must able to name the RFC number. In the share screen I'm sharing now is the standard which we are using. The DVB standard, okay, and the protocol independent multicast, which used for distribution from the video head end to the edge. So via our IP/MPS network, so our service router does the trick and deliver all the way to the edge.
Mm-hmm.
Also, during the distribution in the core network, we are using also the perfect stream, which is a multiple multicast stream deliver. It's not multicast stream, it's multi-protocol label switching, okay?
Mm-hmm.
And it's independent, it's the PIM to the edge using the 20 ST 2022-7 that there are approximately 248 companies at the moment are using it. Okay, if you go to this for Alliance, and you will
Mm-hmm.
find all the 248 company. Okay,
Mm.
it's not
Interesting.
new. There are lots of people already using it. Okay,
Yeah.
and then at the edge, what we do is that we're using if the device can and the network segment can support multicast, we
Mm-hmm.
use IGMP V2 or V3, and
Mm-hmm.
we recommend the customer to use a V3, so it has a more security built-in, and we do not have the problem of the duplicate multicast IP address.
Mm-hmm.
If the network cannot support multicast, we will use a router unicast. So the device will send the request of RTCP request of the specific content or the
Mm-hmm.
channel, and according to the standard of the RTP standard, and subsequent is 3550. Okay, so it can send the video in from the video server, pass through all the NAC address to the device, because the device opened the NAC port in the network, so it go through all the traverse, all the home gateway, go to the carrier grade NAC, and then go to the server IP address. Typically, our service router is sitting first hop in the network. For example,
Mm-hmm.
when you get into the internet, the first element will be our service router, the BNG, and subsequently we are sitting right at the edge, so it's our advantage. For example, hold the entire country, in a few countries, they are all using our service router at the
Mm-hmm.
edge, so we are already in the right place at the right moment. All they need to do is just enable the service.
So if that if it, so it yeah, sorry for interrupting, but if that physical device, that router is already in place, then it's really a matter of just enabling the software, right?
Yes.
To be able
Yeah.
to. So what you're saying is that there are some customers who may have access to your technology but don't even know it, right?
Or they are having different villages. They believe that TCP
Ah,
is the only way, and
TCP. Yep,
they
yep,
do not want to
yep.
enable it. They
Yeah,
or
interesting.
also um, that is a conflict of the decision making. Okay, the
Yes,
decision making guy,
yes.
they say everyone using TCP, we're going to follow the trend,
Yeah,
but
yeah,
they are not aware of that. They're burning money. They already
yeah.
have the everything in place, and all they need is just switch on the services.
Interesting, interesting. Um,
Now I'm showing
maybe,
the
maybe,
yeah.
maybe, yeah, yeah, Keith. Before you continue, I don't want to lose this issue of TCP versus UDP. Um, can you explain? Because I think that there are certain video engineers who are not working at the network protocol level. And I'm not suggesting they don't understand or know what TCP is or what UDP is, but I don't know, I wouldn't assume that everybody listening really understands. So can you give a 1 minute, crash course on
Okay.
TCP protocol versus UDP?
Okay. UDP is unreliable transmission, but we are using RTP over UDP.
Hmm.
Subsequently, we have the sequence number. We
Hmm.
mark each packet the sequence, and
Hmm.
so when the receiver receiving this packet, they look
Hmm.
at the sequence number. If there's a gap, they know that it's the packet loss.
Mm.
Okay, so they can ask for the retransmission using RTCP protocol, which is a standard. Okay, it's been
Yeah.
around since 2004.
Yeah.
Okay, many people are using it. For example, some video conference application, they're already using it for a long,
Mm-hmm.
long time.
Mm-hmm.
And so the RTP protocol packet can be delivered via multicast. Okay,
Mm-hmm.
you can just map the MPEG transport stream into the RTP protocol. So you can
Mm-hmm.
just put into the multicast buffer, and then you will send it out automatically without any problem. So on the network side, our service router will pick up the packet and say
Mm.
that, I need to replicate this packet is to deliver this IP address. This is the
Yeah.
multicast group. These are the people who would like to receive the multicast packet.
Mm-hmm.
So first thing is our fast channel change retransmission server sitting at the edge at the BNG level. So
Yeah.
every of the one of the service router will
Mm-hmm.
receive the multicast one copy only. So you do not need to send multiple time
It's great.
to
Yeah.
waste the network resource
Yeah.
and also the power supply to deliver each packet multiple time to the edge. So
Yeah.
this way we can send the multicast from UK or from one of our customer. They have a multicast video head end in
Mm-hmm.
Germany, and they send
Mm.
to another country across the whole entire Europe, just using the GLE, general encapsulation protocol
Mm-hmm.
in the network. That is what you use for the all other communication purpose. So you use GLE, you have a private pipe, and then you send your multicast into the edge as you
Mm.
wish. You cannot lose the packet because we use ST 2022-7 to have a
Mm-hmm.
multiple path. So in case of one path we lost, and the
Right.
other path will take over. It's not only made by us, made by over 200 company. So you
Yeah.
can pick whatever you want.
Yeah.
And of course, we
Interesting.
will recommend the customer to use ours because we are the best. Okay, as usual. But typically, the customer just pick ours because they already have the network equipment in place. All they need
Understand.
to do is just enable the protocol. That's all.
Yeah, amazing. Okay, cool. Well, let's talk about CDN for live over any access. So you've got the architecture
Yep.
diagram up here, I see. Yeah.
Yep. Let me explain that. Okay. So our network overall architecture very simple. It works with both multicast and routed unicast over any access network. Okay. So for example, from the video head end, we take the video live content, either encrypted or in clear. If we encrypt it, we just pass through and optimize it. If we unencrypt it, we encrypt the content with 100% payload encryption. So we just send it out through the network. So the rest of it will be handled by the cast vendor, for example, Verimetrics, Ligra, or whoever.
Mm,
Okay, and also Google now they have the Google Cast and it's
mm,
free of charge, and but they do not provide you the support,
yeah.
and you need to look after yourself. And so we optimize the video in a single location or multiple location. Okay, for example, if you have a multiple location, you have the geo redundancy. If you
Hmm.
do not have the multiple location, you have a 1+1 redundancy. So you will never lose your feed. Okay, so you have a multiple feed and multiple peering point for the video head end. Subsequently, you can protect your video, and then you can go through all the cloud in the network. Okay, so
Hmm.
you can be anyone's service router. It's the core network router, and then reach the edge. And so you can either use our edge router or you can use someone else at the router. But if you use someone else at the router, they may not support what we can do. And so may need to put one of our service router is 1RU, no, 3RU, sorry, the bigger one is a
Hmm.
3RU, is one 3 terabit egress
Mm,
capability. So It's very high capacity.
Yeah.
Okay, 3 terabit. Which PC server can do that in 3 RU? I don't think anyone.
Yeah.
Okay, because it's a special chipset we make, like the
Mm.
one you guys have for the
Yeah.
video processor unit. So you need to use the right tool for the job. Okay.
That's right. Yeah. How many users can that router handle roughly? I mean, I know you said it's three
Yeah. Okay.
terabit capacity, but
We
you
can
know, how
support
many
up.
sessions?
How many session is
Yeah.
depends on the configuration. The minimum configuration is 256K per card, and then you can scale up to 8 million session.
Mm.
So
Mm.
one single service router can serve 8 million subscriber.
Yeah.
So
Yeah.
I am not sure. For example, take the use case in UK, 60
Mm-hmm.
million population. Let's
Mm-hmm.
say half 50%.
Mm-hmm.
So it's only 4 or 5 surface router can serve the whole entire country.
Interesting.
So
Wow. Yeah. Now the alternate routes, would those come through that same router? They would not, right? They would
no,
come
no, no,
through
they
a
will not.
physically
We use
different.
Yeah, we use any cars. So the nearest
Yeah.
device to the service router will
Yeah.
have the lower cost of the route, and
Okay.
subsequently we will get the request, receiving the RTCP request, and then
Yeah.
it will send the video stream to
Okay.
initiate the video stream. Either
Okay.
we start with always unicast.
Yeah.
When you catch up the multicast live, you will try
Mm-hmm.
to fall back to multicast, and then you will release the resource from the
Mm.
service router itself, and then
Mm.
just go to any sort of switch or router can
Mm-hmm.
provide the multicast. Okay, for example, in
Interesting.
the mobile network case RAN, so we would for those who are using the Nokia mobile network, they can
Mm-hmm.
use the multicast, but on the mobile signal side, on the RAN radio side, is always unicast because due to the layer two,
Mm-hmm.
they cannot support a real multicast. Okay, it's a
Mm.
single point to point. And for the fiber or trace pair, we will just let them, if the multicast enable, we can just send the multicast to all the way to the home. Doesn't matter.
Mm-hmm.
Your or whatever you can support the network, or the
Mm-hmm.
device can support multicast. You will join the multicast. If no, the device will tell the service router, say that, hey, I cannot receive multicast. Can you please continue sending me the unicast?
Mm-hmm.
So in each service router, we can put scale up to from 1 terabit to 3 terabit as a minimum.
Mm-hmm.
And the biggest service router is the 216 terabit. So I don't think we need more than two
Mm-hmm.
in any country at the
Yeah.
moment. So we
Amazing.
typically selling the smallest one is a 3 terabit chassis. And so
Mm-hmm.
we can provide the best service and the cost.
Mm-hmm.
And for example, some customer using CMTS, the cable guys, and they can do the same thing because we can provide the unicast to start up the streaming, tuned in the channel, and then once reaching the live, catching up the live because we buffer in the device up to the encoder buffer, and then it will finish because it say, okay, I finished, I reached the live because
Mm-hmm.
is the I need to join the multicast, and
Yeah.
so the CMTS a little bit tricky on the cable network. It will need to go all the way to the back to the video end to send the service group
That's
back
right.
to that, and it would take between 7 seconds to 15 seconds. That's what
Yeah.
we measure, and we can use the continue the extended unicast to keep the video going until the multicast arrive at the
Mm.
cable CMTS node. And so you
Mm.
can join the multicast and that's it. And then we hand over. So it's very flexible. It can be can support either multicast enabled network or
Mm-hmm.
unicast only network. Okay. For example, some
Amazing.
of the surface router cannot enable the multicast
Mm-hmm.
and at the BNG layer, and subsequently they need to keep going with the unicast until they've been replaced. Okay.
Hmm. Yeah. Amazing. How many how many solutions are out there that can seamlessly switch between unicast and multicast?
Um,
Because that
Seamless. I think that's at least two
okay.
other guys doing that. Okay, I know that. I know of. One is called, once upon a time, they called Microsoft.
Yeah.
And now it's a MediaKite, but I'm not sure if they still good using that.
Mm.
And the other guy is, I know you know who. They used to be called Arroyo,
Yeah.
and now it's bought by some other company, another company. So I'm not sure. To my understanding, they stopped because they
Yeah.
took the decision that TCP is the best, and they all
Hmm.
disband all the development, and then all the engineer who have the knowledge, they gonna
Yeah.
disappear.
Yeah, yeah, exactly. That's what happens often
Yeah.
in these situations.
And the other
Yeah.
guy is called Sai, as
Yes.
the
Yeah,
Amazon.
that Amazon
Yeah,
acquired them.
and
Yeah.
I've not yet able to test the solution yet. I'm not able to find any commercial deployment. So if the guys from Amazon is listening, please let me know where I can find them and I can do some testing. Okay. So I would
Got
like
it.
to do the take the Wireshark capture because I've been doing the Wireshark capture of the Prime Video or for the
Hmm.
live broadcasting football Premier League in UK, and they're using TCP only at the moment. Okay,
Hmm.
and I
Hmm.
still not able to find the side protocol in
Mm.
deployment. I've been told that they're in Sweden, so I will probably will need to go up there and then sit in someone's home and try to take a look what they're doing.
Yeah. Yeah. Yeah, exactly. Amazing. Yeah, very cool. Well, is there anything else architecturally that you want to highlight? Because I would like to move then into like practical applications. I know that you're actually in production and you've got, you know, some real world data to share and real
Yeah,
world case studies. So,
yeah, we've been in production for quite a while, and we've been very quiet because we bound to some agreement not to
yeah.
publicize that, and
Yeah,
so now,
that happens to all of us. It's quite
yeah,
frustrating.
yeah,
You're
and
doing
now
all
we,
these really great projects and, you know, these great events and we can't tell anybody about
yeah,
them. So,
and now we can, and because that restrictions end a few years ago, and so
mm,
we can start to we start our
tell
development.
the
Actually,
secrets.
tell the secret,
Yeah.
and actually it's not real secret because of all
Yeah.
standard protocol.
Yeah,
Okay,
exactly. Yeah, yeah, yeah.
so what our other architecture wise, we have the called a CDN in your pocket. Okay, that is very eye
That's
catching.
catchy. Yeah, yeah, yeah.
And I didn't even think of it when I did it because I find the CDN in my pocket in my mobile phone. Okay, so I say, what the hell I should call this? It's the
Yeah.
CDN in the pocket, so let's just call it CDN in your pocket. So
Yeah.
what it does that we put our client library agents
Mm,
integrate with our segmenter. Actually,
mhm,
we already done the segmenting in the video head end
mm,
while we are doing the encryption. So we can
mhm.
encrypt the forecast or encrypt it for DRM because there are different encryption scheme. So
Yes.
we already make the decision, say that we now encrypt that for DRM. So we tag the segment
Mhm,
in the video head end. All the heavy lifting already done
mhm, mhm,
in the video head end. So when the client receive that, you know that this is for the DRM,
mhm,
and we have also the segmenting tag in it, so we know which segment it goes to. And so, of course, there's some encryption and also the encoding restriction for the
mhm,
DRM. So we need to start with the iframe and with the group, and so subsequently we will have the close group. Otherwise,
mhm.
the segment will start with someone else, video or audio. It will not
Yeah.
looks good. So
Yeah.
what we do is that after we segment that, we transform it into CMAS format, which will be common to all the different player in the HTTP world. And then we can use a HTTP server or MOQ server. I will not recommend to use MOQ server because it's not stable at the moment.
Well, we're going to talk about MOQ, but let's put a pin in that.
Yeah. Okay. So you can just put this real nice agents,
Yeah.
okay, in your pocket, in your mobile phone, or you can put it into your PC, laptop,
Mm,
or in the home gateway. So
mm,
any home gateway which support Wi-Fi 7 can
mhm.
support the OCI. It's an open cache,
Yeah.
open container initiative.
Mhm.
Okay, so we can put this whole thing into the home gateway or into the Mac. Okay, it's a mobile edge compute, which
Mhm.
and then you can do this, or you can put it on your Raspberry Pi, the cheapest computer
Yeah.
in the world,
Amazing. Yeah.
or you can put it into the Jackson, okay, the latest
Yeah.
toy
Yeah.
from our friends in Taiwan. So you can
Yeah.
and you can put that in there. So it just work, okay, because you can also this way because you are inside your own subnet. It's a
Mm.
private network. No one
Mhm.
can do the latching.
Mhm.
CDN latching will go away
Mhm.
unless you want to hack yourself. Okay, if you
Mm.
hack yourself, everyone will know that. Okay,
Yeah. Yeah.
so so this way we resolve a multiple problem in one go. Backward compatibility, we solve the CDN latching, secure. So also we can restrict the number of connection.
Mm.
Okay, for example, you only allowed to have a 4 connection. So after you use all of them, it's your problem, you finish. So you
Yeah.
can stop all the hackers because
Hmm.
you're at a home network inside your mobile device. Who's gonna
Yeah.
hack your mobile device? No one.
Yeah. Yeah.
Okay, unless you're going to do it yourself. Okay, that is another
Yeah.
problem.
Sure. Yeah.
You can just take the video camera and then in front of the TV and then you can
Yeah.
broadcast it.
Exactly. Yeah.
So
There's always a way.
yes, always a way to hack it.
But
So doesn't
yeah.
matter. So this way we resolve the problem of drifting. So you can
Mm.
still use the good old player
Mm.
HTTP player, but no more drifting because the
Mm.
probability of packet loss inside your mobile phone is literally zero. The round trip
Mm.
delays is zero. So even you
Mm.
put it on your home gateway, the probability of a packet loss is still high, but you will not as much as what you're in the open internet because
Mhm.
it's your home
Yes.
network. You know that
Yeah.
it's getting bad, and then you say, okay, I need to switch off the microwave or stop the dishwasher to watch the TV. Okay, that is actually my dishwasher create a lot of noise. So
Yeah. Yeah. That's it. Really, that's interesting. A lot of RF.
no, yeah, on the mobile, on
Your
the my Wi-Fi,
your
my
dishwasher.
dishwasher is creating a lot of noise.
What kind of
Okay,
dishwasher do you have?
I have a dishwasher 15, 16 years old.
Oh,
So
okay.
it's very
Because
reliable. I'm not going to change it
yeah, yeah, no, no.
until it
The
breaks.
reason I ask is, there's all these new smart home appliances, and
Yeah, I know.
they all have Wi-Fi transceivers in them, and they have NFC and
Yeah.
all of this Bluetooth all built in. So I thought,
Yeah. My
that's actually a
my
really
washing
good
machine does
point.
that. My
Yeah,
washing machine does that. Okay, and it
yeah,
will send me a text a message to say
yeah,
that I finished the
exactly.
washing, and
Yeah,
now you can take them
yeah,
out from the washing machine. But the
yeah,
dishwasher is 16 years old, so
yeah,
it's
yeah,
a good
yeah.
old analog one. So
Interesting, but it's still
but
noisy on the
very
network.
noisy.
I
The
mean,
motor is
RF.
very old.
Yeah,
Okay.
interesting.
So this way, we resolve the problem of compatibility with HAS player, okay,
Mhm.
HTTP adaptive streaming player. So
Mhm.
that we solve a multiple problem in one go. Okay.
Mm. Very, very interesting. Wow. Okay. I know that you have done some large sporting events, so maybe you can talk about some of that work.
Yes. Let me talk about the different sort of technology. What we use, we've been testing. We've been testing our solution of channel sharing, and
Mhm.
this the measurement. come from our customer and also from our other vendors. And so we can manage to get down to the channel serving
Hmm.
startup time. The lowest one is 19 milliseconds. That was measured in our customer's lab. Literally, the server is around 50 meters from the from
Mm.
where we are doing the testing. So only one switch, two switch in between. So
Yeah.
that was extremely fast. And the maximum is typically is around 350 millisecond to 500 millisecond.
Mm.
And we did the measurement in Sydney from the server was sitting in somewhere in Northern Europe. And in
Mm.
Sydney, between Northern Europe is around 420 millisecond. So the channel change times around 500 and something. Okay,
Hmm.
500 millisecond, because we need
Mm.
to take into consideration of the round trip delay plus the
Yeah.
starting up time.
Yeah.
So we compare with other solution is the typically from 2 second to 4 second up to around 14 second. Okay,
Hmm.
that is the quite high. Okay,
Mm.
it will depend. If you have a lot more packet loss on the way, TCP will start up time with 200 second or even 300 second. Okay,
Hmm.
so around 5 minutes. That is what we're measuring, but typically it should arrive in 10 to 14 seconds.
Yeah. Yeah.
And compared with the other technology or latency, we have make the assumption that the camera plus the encoder, everything is around 5 second delayed. And then compared with our solution, we are more or less the same as the digital terrestrial TV. In US,
Hmm.
they call OTA,
Hmm.
over the air,
Yeah.
and also DTH, the satellite, because satellite has a one disadvantage. You need to go up from the teleport to the satellite and come back down. Okay,
Hmm.
so that will cost between 800 millisecond to 1.2 second or even 2 second, even more.
Mm.
Okay, depends on where you have the satellite. And we compare with the traditional IPTV. The IPTV, without the fast channel change, we need to wait for the iframe. And
Mhm.
subsequently, they typically have a drop size of 1 to 2 seconds. So they will increase approximately 4 seconds of a latency due to the wait for the IGMP join.
Mhm.
Okay. And also
Mhm.
once it join, and it will also introduce the accumulated latency.
Mhm.
All the people they're claiming that they can do ultra low latency, they're using WebRTC. That is
Mhm.
more or less similar as ours, because of WebRTC, the underlying protocol is RTP.
Mhm.
Okay, so they can achieve that, no problem. But WebRTC, they use a full error correction, and that is the killer point, because they cannot support a high degree of packet loss. For example,
Mhm.
random packet loss of 15% in
Mhm.
mobile network or in a Wi-Fi network with a lot of noise. You can kill the connection. Okay,
Mhm.
WebRTC will be dead.
Mhm.
And also, if using datagram of a retransmission, a lot of people have a difficulty to get it work. So they have a difficulty to get it work. So they WebRTC typically can support up to 3 to 5% of random packet loss. After that,
Mhm.
they would be just unwatchable.
Yeah.
Okay.
Yeah. Yeah. I think a lot of people who have attempted WebRTC at scale, and this is why the vendors who have really built, I would say kind of real solutions with WebRTC, um, they have done the engineering work to actually build that reliability in. The problem is that a lot of people who haven't actually tried it at real scale, they just, a handful of streams, one to a handful of viewers, they go, this is great. This works. This is amazing. It's out of the box. It's an out of the box, free, low latency solution. I mean, I'm paraphrasing, but that's usually the view. As soon as you start to scale it, it gets unreliable really fast,
Yep.
and those are I think that's what's super important for the listeners and hopefully the viewers, if you're able to watch the video here, is that this slide that Keith is showing, is really critical because there's the reliability vector,
Yep.
that cannot be lost. It's one thing to stream one stream, a single stream to a handful or a single digit hundreds or maybe even single digit thousands of viewers. That's one thing. To do that at tens of thousands, hundreds, and millions, forget about it.
Yep.
With a lot of
We
the solutions that are out
yep.
there now.
Yep. We have a million subscriber concurrent viewer all the
Yeah.
time. Okay, it's
Yeah.
daily, and we look at the customers' log,
Yeah.
quality log. They have a million subscriber on the
Mm.
network all the time. They watch just like broadcast TV
Yeah.
over the public internet or managed network. Okay,
Hmm.
only a few customers they're using open internet because they do not have the network. But most
Yeah.
of our customers, they are ISP. They have their own managed
Sure.
network, so they
Sure.
do not care because a multicast, it can be one to a few millions, doesn't matter. It will
Yeah.
not cost us anything. The only
Yeah.
thing cost is the retransmission. And
Re-
also the
exactly.
retransmission, our service router capability can handle millions of sessions. So
Mm.
and it does not matter, okay, because sometimes we say that we over engineering it, we just and in some cases we need to do that because the
Yeah.
when the network's really bad, they lost a lot because
Yeah.
in one of our customer we've been measuring is 40% of random packet loss.
40%. Wow.
Yes,
Wow.
that is in the fixed wireless access network
Yeah.
because the
Yeah.
attenuation of the radio signal down to
Yeah.
minus 60, minus
Yeah.
80%,
Yeah.
minus
Yeah.
80 dB. So literally they have no signal at all.
No
The,
signal.
the
Yeah,
bandwidth
exactly.
is extremely low. So we need to scale down the bit rate when the buffer
Incredible.
is empty. Okay, so
Yeah.
we use the standard adaptive streaming kit technology. When the buffer is empty, we just drop the
Sure.
bit rate. Okay.
Yeah. Yeah. Amazing. Yeah, that's incredible. Um, Okay. Wow. This is really interesting, Keith. And I hope the listeners are enjoying this. One of the things we're really trying to do here at Voices of Video is to go a bit deeper. I appreciate higher level discussions, and I think they're very appropriate and needed. But it's why we're going to be bringing on more experts like Keith to come on the show and really do deeper dives, into protocols and standards and technologies and real world implementations. So I really appreciate what you're talking about here, Keith. Thank you. Thank you. Maybe what we should do is, let's talk about the practical implementation. So we've touched on that. And, I made the point, or I asked the question, then also made the point that, there's probably some platforms that have access to this solution, but either don't know it or, like you say, have chosen to support, a different set of technologies. Um, but do you have any case studies that, you could share with us? Maybe some examples of where
Yep.
you have deployed. How long does it take? What are some of the complexities? How difficult is it? Just talk to us about that. Because as you well know, because you're in infrastructure, one of the biggest challenges working in video is that, there's always a better codec. There's always a better standard. There's always, and I'm using air quotes, a better way to do something. But the devil, the famous saying, the devil's in the details. I like to say the devil's in the implementation. So if it's either too hard or too difficult or too expensive, then it doesn't matter how good it is. So talk
Yes.
to us about, the implementation.
The implementation is very simple. We have only three major element in the network. We need to
Hmm.
deploy. One element in this architecture diagram is the video optimization. The MPEG transport stream, we need to
Hmm.
optimize the packet. So
Hmm.
we group all the video by frame type. And also we try to reduce the encoder buffer size.
Mm,
So we try to make the audio alignment with the video. And
mhm,
a lot of encoder, what they've done is that they are not using a proper chipset like yours.
mhm.
Okay, they're using some standard PC software hardware,
Yeah,
and then the audio packet always in the end of the GOP or even
that's
beyond the
right.
GOP.
Yeah,
Okay,
that's right.
so that will cause a hell of a lot of trouble to
Yeah.
wait for the audio packet to arrive to start the decoding.
Mm.
And if you use some very nice hardware encoder, and
Like a NetInt VPU.
yeah, of course. That is what I've been talking with your guys. And
Yes.
when I first met Alex and he
Yeah.
present me the VPU, I say that is the chip we need to
Yes.
tell everyone to use it, because
Yes.
you can
Yes.
encode it, compress the video very
Yeah.
fast, and also you can optimize the video and audio alignment.
That's right.
Okay, because
Yeah.
all other guys cannot do it, because they need to wait for the complexity
Yeah.
of the video compression. They talk about all the AI, that is rubbish, because the basic fundamental thing is that you need to compress as fast as possible,
Yeah.
as a
Yeah.
minimum bandwidth as
Yeah.
possible, but you need to
Yeah.
align the audio with the video. If you put the audio packet a few seconds behind the video,
Mm.
you will need to wait for that, otherwise you have
That's
the lip
right.
sync problem.
Yeah.
Okay,
That's right.
so
Yeah.
when Alex told me that, I said, okay, Alex, can I have one of those?
That's right.
But with the
Well,
software.
we're excited. We're excited to support you. I know that you guys are going to start a new, round of evaluation and testing, and and again, on Voices of Video, we really steer clear of promoting NetInt products, but I do have to give a little bit of a plug here because. After several years of talking to a lot of network providers, owners, the hyperscalers, and working with them. Everybody was interested from day one, but it took time to actually for the hardware to make it into the network. The good news
Yes.
is that we're now in some very large, very significant networks, and so now you don't have to be a very large VOD platform, SVOD or OTT platform to use the products, which is great in combination with what you guys have built, then this is going to be really powerful for the industry. So,
So the second element in the network would be our service router. So,
yes.
or you can either at the video head end, so we can send out the packet, route the packet to the edge, or
Hmm.
we use someone else surface router. That's
Hmm.
why I normally do not draw the diagram of our surface router in the video head end,
Yeah.
because otherwise it will say that only work with your surface router proprietary. No, you can use anyone's surface router to do the
Mm.
job.
Hmm.
And then the key element is that in the video at the edge, you need to enable certain features and
Hmm.
also some additional card on top of it to do the job.
Hmm.
Okay,
Hmm.
because you need to convert the multicast to unicast to do the packet forwarding, and
Yeah.
also you need to do the retransmission, handling all the retransmission. That's a lot
Mm.
of compute capability required. So we
Yeah.
typically use a secondary card to offload the loading from the surface router, but
Mm.
all the routing capability or the security all relied on the video service on the surface router. Okay, so it will send the RTCP request on the surface router by the client device. The client device is really, really tiny. It's around 200 kilobyte only. Okay. The
Yeah, I
fast,
was going to ask. I was going to ask how big it is. So it's 200 kilobytes. That's
yeah,
it.
200 kilobyte.
Wow. Okay.
Okay.
Yeah, that's tiny.
It's tiny.
Yeah.
Um, the fast the guys ever integrate our software library into the device is 1 hour. But I would not recommend to anyone to do that, because that is the expert level,
Yeah, yeah.
extremely level, extremely expert level. Okay,
Yeah.
don't try it. Okay,
Don't try
um,
it at home.
don't try it at home.
Yeah.
We have seen that typically from graduate engineer, they pick up the documentation, they pick up the software library, and use our pseudocode, and then
Mhm.
they do the integration. It's typical between 1 to 2 weeks, because it takes a week to read the documentation
Yeah, sure.
and then ask all the question.
Yeah.
And we typically know that which question they're going to ask, because we
Mhm.
test those guys if they have read the documentation. Okay,
Yeah.
if they do not read the documentation, they will not ask the question. If
Yeah.
they ask the question, we prove that that guy read the
They,
documentation.
yeah, yeah, yeah.
Yeah,
They read
so
it.
we know that when we go to meet those people, or on
Yeah.
the meeting online or in person, we
Yeah.
ask them, so do you have this question to
Yeah.
ask? And
Yeah.
they say, if no, I say, okay, you let's forget it. Let's go back, and you're going to read the documentation before we can go ahead.
Yeah. Yeah.
And so afterward, integrate with this into the set-top box or mobile device, because we can integrate that into any player as an agent.
Mm-hmm.
Okay, so we do not use an app anymore. We use an agent, and
Mm-hmm.
it's easier for anyone to do the integration job. And so
Mm-hmm.
they can do the integration with the app or whatever, or
Mm-hmm.
agent in the container. And so we can deploy it in any operating system. So we do
Mm.
not restrict it to Android, Linux, or iOS. We just build
Yeah.
one single library for every single one.
Yeah.
So that will make life easy for everyone.
Amazing.
So these are only three elements plus the manage the platform. So that is only need to use once or twice, or doing the
Mm-hmm.
monitoring, or you can build your own OSS and
Mm-hmm.
to monitoring the system or the network element. So it's only three major elements. So it's very simple. In the practical term, is that most of the people can put the element, an element with our wrapper is the video appliance that is the optimizer, video
Mm-hmm.
broadcast optimizer. We
Mm-hmm.
optimize the video for IP delivery. Okay,
Mm-hmm.
so we ensure that the IP delivery will be perfect. So we need to have proper MPEG transport format
Mm-hmm.
over RTP, and then we will send it out to the edge, and then the end device will play back as whatever they need to, with any sort of encryption. It's agnostic to us, the encryption, because we leave the path header in clear. So we know that this is iframe, bframe, audio, this is new packet. So we group
Mm-hmm.
all the TS packet into one single RTP. So in the future, in the CDN in your pocket, so we can use a minimum size of the trunk as a one
Mm-hmm.
RTP. So that
Mm-hmm.
means a 188 byte of the TS multiplied by 7. So,
Mm-hmm.
or even less, depends on if you have a padding or no. So you can
Yeah.
have the minimum size of the trunk. So you can deliver to the player, and that's it, finish. It's very simple.
Amazing. Amazing.
It's very reliable, and we've been
Oh.
doing this of testing with one of our customer,
Mm-hmm.
and in the POC just before the pandemic. And during the pandemic, we shut down everything, because no one allowed to go to office, and no one
Yeah.
can go around. So we just wait until the pandemic finish, and also the patent grant for the chunking and the
Mm.
segmenting. So we have a few
Mm.
patents on that. So
Mm.
it reduced the live latency during the chunk segmenting, and for the trunk as well. So deliver, so we can make sure that the deliver to the hash player is perfect smooth, no more additional latency. Otherwise, you will need to wait for the whole entire trunk segment before you
Yeah.
can deliver. Or you can use the trunk delivery, but you still have the byte range to handle. You still
Yeah.
have the latency. But the
Yeah.
way we do it is completely eliminate the latency on the segmenting.
Yeah. Yeah.
So
Amazing. So, Keith, you have given us a master class. This is way more than I even anticipated. So, thank you. um, I want to wrap it up here. There's a lot of talk in the industry about media over quick, Mock. How does that fit And is it viable in your view? I know you're going to have very clear perspectives. Some will say you have a biased perspective. That's okay. But I'm very interested in your response
Yes,
and your thoughts around Mach.
MOQ is based on the quick protocol. MOQ
Yeah.
is not a protocol, okay, guys? And we need to emphasize one thing: MOQ
Yeah.
is not yet a protocol until someone to make it protocol.
Yeah, that's right.
Okay, so it's just a, a quick protocol have a one simple defect. Okay, if you're using timeout for the retransmission, you have the very huge latency, and the efficiency of the retransmission will be extremely poor. Okay,
Mm,
it's not the problem of that you can deliver fast enough or not. It's how reliable you're going to be delivering those
mm.
live stream
Again,
packets,
reliability. Like,
reliability and
yeah,
scaling.
yeah,
Okay,
scale.
and also MOQ at the moment cannot use multicast.
Hmm.
Okay, we need to use a lot of relay, and the relay itself is similar to any caching server, and it
Hmm.
has the cache delay, and also you have the all sort of which redirection delayed. Okay, packet
Mm,
forwarding delayed. So
mm,
uh, been talking with some people. They're using the datagram retransmission. They have improved a little bit. For example, quick protocol, I tested. Um, Actually, you can just take any YouTube, and then you just luckily find the one with quick, and so you can introduce some late round trip delays or packet loss. I do have
yeah,
one at home and
yeah.
also in the lab, so I just impaired the stream, and then after 3% of a random packet loss, it just dropped down to very low bit rate, or it fall back to TCP.
Hmm.
Okay,
Hmm.
so and in the MOQ, I've been talking with someone who are working on it. I cannot name them because I need to the permission to to before I can go into talk mention their name. They are
Yes.
using datagram retransmission. It improves significantly of the retransmission. Okay,
Mm,
it can support up to more or less near to 10% of random packet loss, but that is still not sufficient.
mm.
5% random packet loss, they're already scaling down the resolution. Okay,
Yeah.
I've been testing that one from 4 megabit, it down to 400 kilobit.
Mm.
So it's not a TV. Okay, you cannot
Yeah.
watch the
Yeah.
football like that. You will look for this on the TV screen, say where the hell is my football?
Yeah, exactly.
If
That's right.
that's a golf ball, even worse. Okay,
Yeah, yeah. It's true.
and so that uh, quality problem with reliability problem, that is still a problem for MOQ. And
Hmm.
also there's a lot of people, 2 million chefs in the kitchen. Okay, everyone want their own stuff into the
Yes.
MOQ. I'm
Yes.
not sure when the hell it's going to be ready. Okay, when you're ready, let me know, because
Yeah.
the 2 minute chef in the kitchen
In
is
the
not.
kitchen. Yeah. Yeah.
It's good and bad. Okay, good thing is that everyone will contribute, but if they
Yeah.
all pulling the water to their own mill, water mill,
Yeah.
and there's going to be not enough water for everyone. Okay,
Yeah. Yeah.
so
That's right.
so that's a quite a lot problem, and
Yeah.
someone need to stand up, say that this is the way and this is the reason.
That's right.
I'm not sure that will work. Okay, but
Yeah.
using RTP is different because the standard is already there, everyone can use it, just go, hit and go.
Yeah.
And the
Yeah.
only thing is that the retransmission, anyone know how to do the control theory.
Hmm.
Actually, I can tell you that not many people now learning control theory because they're all doing the software engineering. They do
Yeah.
not teach that.
Yeah.
Okay,
Yeah.
and if you do the E&E, electronic engineer, or aerospace, aeronautic and aerospace engineering, the one
Hmm.
who do the did uh, SpaceX,
Hmm.
and they know how to do the control theory. Okay,
Yeah.
they can control
Yeah.
rockets such a
Yeah.
size.
Yeah.
So it's very simple because you just need to control the error. Okay,
Mm.
so you just correct the error, apply the control theory algorithm, and that's it. It's very simple.
Mm.
And that is how we managed to handle up to 40% of random packet loss, or
Yeah.
even 50% of the periodic packet loss. For example, every 300 milliseconds, we lost 100% of the packet,
Mm,
and the next 300 milliseconds no loss, we
mm.
can still watch the video perfect. Okay,
Yeah.
so
Amazing.
that is
Yeah.
the quality we need to do.
Yeah.
And a lot of people try to say, you do not apply the loss into your network, your testing. I say that is not right, because in the network is OTT. It
Yeah.
may or may not get there, and may or may
Yeah.
not have the random packet loss, or may or
Yeah.
may not have the bursting noise. For
Yeah.
example, the
Yeah.
microwave can generate a 300 millisecond bursting
Hmm.
loss. That's why we
Yeah.
test the 300 millisecond loss, because due
Yeah.
to the microwave, because we watch the microwave, and then how long is the bursting it lasts, and then we say,
Yeah.
okay, that is the test case we need to do.
Yeah.
Okay, so
Wow.
we
Wow.
go around and measuring all the loss in the network, because we are capable to do so. We have the
Hmm.
opportunity to do so, and so we managed to characterize the loss in
Hmm.
different network. For example, in the fixed wireless network, we find out 38%. Actually, in the book, someone's written a book about that. It's 40% random packet loss. I say, holy, that is a really challenging one. So we just did that. Okay, so we just managed to get the 40% random packet loss and repair. Uh,
Hmm.
that is the edge. We need to, at the moment, we try to push it, the random packet loss, up to 50%. That
Hmm.
is our target at the moment. And
Wow.
I'm not sure
Wow.
if that can be done,
Yeah.
but that is
That's
quite challenging.
that's amazing. Yeah, that's incredible. Well, Keith, as I said, thank you so much for your time and for the deep dive that you gave us, in zero latency, zero drift. I really like how Nokia's focused in this area, and I learned a lot. I hope our listeners learned a lot. So we'll have to have you back. Maybe we'll do a follow-up session and we'll bring in more about the NetInt VPUs as a part of the solution as well. And we can maybe talk about a customer, a platform as well that's using the solution.
Yep.
So that would be
Okay, good.
wonderful.
And
Yeah.
here's, I just show you that as a use case
Mm,
study we done
mm,
in Europe, in Italy
mm-hmm,
actually.
mm-hmm.
And I watched the football match, England against Italy, Euro 2024.
That's right.
And we are 2 seconds ahead of the DTT T2 DVB T2. So we have a negative latency compared with the broadcast TV.
Mm-hmm.
So that is surprised me, I can tell you that.
Yeah.
When I saw that, I say, oh, that means someone in the DVB, in the broadcasting, they have the delayed, because the broadcast cannot have the delayed. So that
Mm-hmm.
means they have contribution delayed compared
Mm-hmm.
to ours.
Mm-hmm.
Because
Yeah.
wherever we arrive, we just send it out. Same for them.
Yeah.
So that is how good we can do.
Interesting.
Okay.
Interesting. Wow. That's great. Well, good. Well, thank you again for joining us on Voices
Yep.
of Video, and we will have you back, I know.